Okay, hi. Today I wanted to show you a T-square and some instruments for drafting that enable us to make sure that we make things square, which may or may not be obvious as to why. So this is a T-square. This is a kind of a large one, and it has measurements on it like a ruler. The thing that's interesting about this T-square, or all of them, is that they're fixed right here. Okay, so this is bolted together right here, and it's rigid, so it's not going to move around. It's going to stay, and it's going to maintain that shape, which happens to be a 90-degree angle, which is what's the angles in a square. So in a real square, you have 4 corners, 4 sides. An equilateral rectangle is a square. This is a rectangle that's not quite square, but I'm just going to talk in generalizations here. So this is what's called a plane square, and the square that they're referring to is this 90-degree angle. So this is 90 degrees right here. It's 1/4 of a circle. Okay, it's 1/4 of a circle. Very important thing, this whole quarter, that we'll just keep going back to. What is a quarter of something? So anyway, the object with this item, this T-square, or a square also, is that you can do mechanical illustrations, blueprints, or for whatever you're doing, and you can make sure that they're square. Why is that important? Because let's say, for instance, we want to cut a panel of this wood, and we want a panel that is square, because we want something to look or be professional and fit in a proper shape. So I'm just going to mark this off for you and kind of show you how a square works. So with the T-square, if you hold it up against the edge of your object, it's nice and straight along there, and it automatically gives you a line that is at a perpendicular angle, which is a exact 90-degree angle, so that you can make your square. So what I need from this item, we're making a panel that is 50. We're going to do 50. See, I need 48 plus 1.5 inches. I'm going to do a 52-inch by 42-inch square. All right. So a panel of sheets of everything in construction are about 4 feet exact usually. So we're talking about this panel of wood right here is exactly 48 inches wide. I need 52, so I'm going to have to go the other way and measure down and get my 52 on this corner, on this edge over here. So I'm just going to mark that off real quick. So we know that this is 48 because that is the length of our T-square. And I can add the 4 more inches that I need to get that. Now, I know that's 52 inches, and if I use this square like this to put it on my point, I'll be at 52 inches on all across that line, all the way down. I need to look and see how well you can see this. Yeah, so if I hold this square up against this edge, like so, all along this line is exactly 52 inches from the other edge, which is down there, this one. Okay? So look, see how that worked? That tool just drew that completely square line right there. It's perfectly square, because that's what a T-square does. See that? See how it fits that line? It has made that square. See that? Square. Perfect. Perfect square. Now I have my 52 inches from here to there, all the way down. At all points, wow, the lighting here is crazy. At all points on this line, is 52 inches away from this edge down here. Okay? That's very key. It's very key to be able to make something square like that, because if you are going to illustrate for someone, and you know, I know the computers are going to do all this, you know, when you're doing it, but you still have to understand the underlying principles, and you still have to be able to do very basic renderings under your own power. You're not always going to want to, you know, pull out your software to do something as simple as a little square like this. So what I want to do now is cut this board for you, but this camera's just giving me too much trouble. Let me get this tripod, see if that'll work. So I wanted to cut this board for you and show you why it's so important that I had that line. So if I'm cutting this board with this power saw, and it's a really nice window here, by the way. What this window does is it allows me to look through here when I'm cutting down into the line that I'm cutting on. So as the blade of this saw cuts right here, the blade's here, and as I cut along the line right here, I'm able to look through this window and see that blade. I don't know if you can see that in there. See how you can see the blade? And I can see on the outside, all saws have this little thing here where you can line up your line there, but this window allows additional viewing there. So that's why it's important to be able to have a straight line in order to even start to cut something straight. And those squares, the T-square, I'll show you later. I want to show you later how important these T-squares are for any kind of drafting or something that you're doing. And in all drafting, you start with this L. The whole L. We were talking about this before with the letters in your name, how they're all actually basic drafting shapes. Okay? So let me see how much this. Yeah, perfect. Okay. So here's your L, right? And when you're drafting something on a page, you start out with this basic shape on the very edge. So you create a border on the left and on the bottom, and that's how you start your drawing. So you start with this border first, and in the bottom here is where you'll put your information, like you know, Ellis drew this, and it's a map for whatever, and that's how you begin to frame your illustration. I want to show you maybe on this side. So if you turn your L this way, you turn your L that way, and you start out like this. So that's how you start your new page, like that, okay? And you would put something down here like, you know, what the object is, what its purpose is, the date, who the draftsman is, stuff like that. And you'll have, now here, this is important, watch this. You need to be able to use these squares to make equidistant lines like this, okay? So that you can have things that are graphical. So in here you would have, you know, who you were, what client you're constructing this for, etc. And down here you'd have, you know, whatever. This is a blueprint. You should note that all draftsmen are expert printers. You should be able to print like a machine. Engineers tend to have very good printing. Okay, so you've started with this L right here. And that's the beginning for your whole illustration that you would put up in here. Okay? Now as you continue to use your T-square, watch this. You put your T-square here, and if you were to draw a line, (43 to 44, 43 to 44, 43 to 44, 43 to 44, you can take your other square, line it up against, so these two edges are matched. No, you didn't get to see any of that? Man. So these two edges are matched. Mark that. Mark that. And you have square. Everything's square, okay? So what I did is I took this and I went 43, 44, 43, 44, 43, 44. And then this one comes across the top. So I have the T-square flush up against the edge of the page or the object. And then the other square flush up against this edge right here. And this comes down and makes my other square. See what I'm saying? So those squares are perfectly square to the page and essentially equal to each other, depending on what level of precision we're talking about. Okay? So if I'm drawing an axle for a car, I take my square again and put it on the edge, like so. Okay? And then this goes right here. And there's the axle for my car. See?